Some of the libraries contain extensions to types defined elsewhere. For example, I could provide extensions for the array type, and I could provide a library containing whatever extensions I wanted to, whatever I wanted to add to that date type. And so all the end user has to do to be able to use my code is to try to use it within their script, and Lasso will automatically find and load all these extensions. The reason that we have these libraries dynamically loaded is because it helps keep memory usage down, because you're only loading objects that are actually used. So there's it can improve startup time because there is a little overhead when you load one of these libraries, and so what you try to do is keep it all out of memory until you actually need it. So in this way, Lasso can start out by loading only the very, very basic bits of functionality, and then over time as it runs, it loads in the rest of the system. Libraries can be as fine-grained as you want. You can split up objects into multiple libraries. You can have one that contains maybe deprecated or seldom used functionality, and put the bulk of the methods that are used primarily most of the time, you put it in a separate one. And this way, this is a method we use for compatibility. So we can provide compatibility for a lot of Lasso 8.5 code, but not have that loaded if you're not using it. So as soon as your website tries to use something that isn't officially supported in Lasso 9, it's provided for compatibility, it'll load that library. We provide quite a few compatibility libraries in that manner. We can also produce a special kind of library file that's a .bc bitcode file. Bitcode is an LLVM format that Lasso knows how to load. Bitcode files are a little different from the native shared libraries that I described because they can be shared across platforms with the same processor. So for example, the same BC file could be used on OS X, x86 as well as on CentOS x86. So BC files are a little more flexible, but they don't load as fast. They have about an 80% larger file size, and they consume more memory. But they don't require GCC, which is one of the advantages. We don't actually ship any BC files, but as an option, if you want to create a file and have it not native to the OS, but just native to the processor, you can do that with the BC file. Compiling can also be used to produce a regular executable file. Usually this is some sort of command line tool or utility, though it isn't limited to that. It's a regular application like you would run. It's not a shell script, though Lasso can be used to run shell scripts using the hash ping that you see in many Unix script files. So Lasso 9 can be used for that. But these are actually compiled natively. And one of the main advantages, aside from the fact that you don't have to have your source code in it, is that they start up executing about 20% faster. Because when you execute a regular script file, Lasso does have to go through all the steps of parsing it and compiling it in memory. But since these are compiled ahead of time, you don't have to do that. So these utilities can process command line arguments. They can read environment variables. You can start other processes using the OS process module. You can read standard input and output. Standard error, you can start new threads, you can do client-server network connections. You can also start up a Lasso server fast AGI listener, so you could make your own Lasso server process that works the way you want it. You can kind of tweak the startup options, things like that. But again, without a serial number, it is running in developer mode. So you would need if you were distributing your own Lasso server process, one thing you might do is distribute also the database that holds the serial number. That's one way to make it easy for a user. Of course, you purchased the serial number from us and distributed it as a package to the user in that manner. These types of apps don't load a whole lot of features when they start up. They begin very bare bones. And by that I mean that they don't load any C API modules. And the C API modules that you would usually load are things like data sources. So for example, they don't automatically load MySQL. But you can load the C API modules manually. It's pretty easy to do. You can tell it to load, for example, everything in the Lasso modules directory, or you can point it to a specific file, and it will load that. So if you knew your app only needed to use MySQL, you could have it load only that module. And again, the benefits for this is speedier startup time, less memory usage. Plus, it's always nice just to be able to use the things that you need to use and not have a lot of extra stuff that's never going to be utilized hanging around in memory. But aside from the Okapi modules, MySQL, etc., you can use our built-in SQLite data source. And you can use this, you can actually bypass inline. So we have a SQLite object, and when you create this object, you give it a file name, and that's the database it's going to create. So also within these scripts, you can read and write the standard input-output error streams, and these are available as objects as well, file objects that are already created for you to use, to just kind of hang around. Lasso C, or Lasso, is the Lasso compiler. This is the command line tool that we include with Lasso 9. It's included in the beta today, and this is the tool that we use for creating all of our libraries. So when you run this tool, you give it the path to one or more .lasso files. These .lasso files obviously contain your source code. You also provide it with a few options on the command line to tell it what you want it to do. And if there's no syntax errors in your source code, then it will produce either an assembly file or a .bc file, depending on the options you give it. And so these files can then be tossed over to GCC to create the final binary. Makefile. So we use Makefile to build our Lasso libraries. Makefiles are run by a tool called Make, which is included in the developer tools. This is a utility. It just streamlines the process of making shared libraries and executables. Make is a very cool tool because it links the files produced by one command to another command. So it operates by executing shell commands, and it assumes that these commands have input files and output files, and it handles cleaning up all the intermediates as you go from one step to the other. So we provide this Makefile. You can use it. It doesn't ship with Lasso 9, but it's generic, and so you can use it to produce your own tools. The way you might do this would be to copy the file into your own project directory. And we tried to make it really simple to produce these utilities. So as an example, if I had a source file that was called tree.lasso, which maybe had my tree object, I would go on the command line and I would cd into the directory that contained my source, and I'd type make tree, and that would produce a tree executable utility that you can run right then on the command line. If you typed make tree.dylib, you would produce a Lasso library, which can be dynamically loaded. These are available in our Subversion source repository, which if you join the beta, the Lasso 9 beta, then you can find the URL to get access to those. We don't use Git.